Shall we get started? Just keep revising the previous concept. I'll wait for 2 minutes. Let others join. On panir. Wi-Fi on panir. Others are coming up. We'll wait for exactly 2 minutes. Wi-Fi on panir. எது ஜூம் பண்றேன் அதுல நான் இங்கே பண்ணிப்பேன் கரெக்டா இதுல மட்டும் இருக்கா பார்த்துக்கோ சென்டர்ல இருக்காங்க இதோட சென்டர்ல இருக்கா இங்க இருக்கா அதுல டிஸ்பிளேல பார்த்துக்கோ கிளியரா இருக்கு மெமரி கார்டு கிளியரா மெமரி கார்டு கிளியர் ஆயிடுச்சா ஆக்சுவலா அதுல ஒரு வாட்டி ஜூம் பண்ணிட்டு ஜஸ்ட் அங்க ஜூம் பட்டன் நமக்கு ஜூம் பட்டன் பிரஸ் பண்ணு சரி நான் இங்க கண்ட்ரோல் பண்றேன் கொஞ்சம் பின்னாடி தரலாம் ரிஃப்ளெக்ஷன் அடிக்கிறது இப்போ வருது பாரு ஓகேவா ரைட்டா Guys, listen. Why again late today? Why were you late today again? இதுவே ஃபாஸ்டா Okay. Listen. See, the next topic that we'll discuss is clock rule. Okay. So the next topic is going to be about clock rule. Okay. So now we know how to use right hand thumb rule for a conductor. So what do? You take your right hand, place it in the direction of current, place the thumb in the direction of current and curl the fingers so that the direction in which the fingers are curled gives you the direction of magnetic field. Okay. The next question is, instead of an open conductor, what if you have a coil in your hand? That is coil or a loop in your hand. So when you have a conductor which is wound in the form of a closed shape like this, then we can think of the current to flow in two directions. One is anti-clockwise direction or clockwise direction. So here if you see, when the current is going to be in the anti-clockwise direction, what will happen is, when we apply the right hand thumb rule, right? So here I'm going to apply the cross product concept. See, observe. If I observe what is dB vector's direction is decided by dB vector's direction is decided by ideal cross. So it is decided by, yes, ideal vector cross R vector. So when you do the cross product between these two, you're going to get the direction of the magnetic field. So in this case, if you observe, I vector at the top is in the leftward direction and R vector towards the center. If I want to find what is the direction of magnetic field at the center, then this is going to be R vector. I told you R vector is always measured from the point where you consider the element to the point where you're trying to calculate the field. Right. So this is going to be the direction of R vector. Right. Now tell me what will happen in this scenario. What is the direction of ideal according to the unit vectors? It is minus I cap. Cross. What is the direction of R vector? It is minus J cap. So what is minus I cap cross minus J cap? So if you take the circle, if this is I, J and K, what is I cross J? It is going to be K. So it is going to be K cap. So what does it indicate? It says that the magnetic field due to this current, which is flowing in the anti-clockwise direction, is out of the plane. Positive Z axis, out of the plane. So which pole has the tendency to emit the field lines? Which pole has a tendency to emit the field lines? It is north pole. So what will happen here is, whenever you face a loop, right, where the current is flowing in the anti-clockwise direction, you're actually facing the north pole. Is it not looking like an N? Right? So whenever the current is flowing in the anti-clockwise direction, observe, I drew an arrow mark in the anti-clockwise, here also an anti-clockwise mark, and just added both of them. So it looks like a north pole. So this is one of the important points that needs to be kept in mind whenever you face a loop. Till now, we discussed only about an open conductor, right? Because this is going to be the connecting point to the derivation which we are going to follow now. I hope this point is clear, right? Yeah. So just give me a minute. Okay. See, suppose I take another conductor like this, right? I take another conductor where the current in this scenario The current in this scenario is flowing in the clockwise direction. Okay. So here I is like this. This is going to be R vector from where to where? From the current carrying element to the point where we are trying to calculate the field. So in this scenario, what will be the direction of dp vector? It is dependent on ideal vector cross R vector. See, this is not the overall formula. I'm only saying that ideal cross R is going to decide the direction of the magnetic field. So what is the direction of ideal vector in this case? It is I cap. So I cap cross, what is the direction of R vector? It is the same minus j cap. So I cross j is going to be k cap. See, I cross j is k cap only, but there is a minus sign because of which you write a minus 4 on. So minus k cap means it is into the plane. So which plane has the tendency, which side has the tendency to receive the magnetic field? It is the south pole. That is why if you observe, here you draw half. So this is in the clockwise direction. The bottom, this is also clockwise. So when you join them, it looks like a south pole. Okay. So the important points to be remembered is next time onwards, whenever we say what is the direction, what is the pole generated due to the current in the anti-clockwise direction, it is going to be a north pole, and the current flowing in the clockwise direction is going to generate a south pole. This is what is called as clock rule. Okay. So you can make a note of this. Done? Okay. Shall I proceed to the next concept? It's simple. My became all the time out. Write it fast. Done. So next concept that we'll see is magnetic field on the axis of a circular current carrying loop. Okay. So topic we are going to see is magnetic field on the axis of a circular current loop or a circular current carrying loop. Okay. First, let's try to understand what it means. See, when I talk about a circular current carrying loop, it should look like a circle, right? It is obviously going to look like a circle when you see it from the front. See, for example, if I take this cap itself, okay, if I take this cap, right, let's assume there is a coil. In the sense, it is not only one turn, there are multiple turns and this thickness has come. Okay, when you see it like this, it looks like a circle. When you exactly see it in this way, that is exactly perpendicular. I think I made a mistake. 1 minute. Yeah. So when you exactly see it in this way, right, it is going to look like a straight line. So when you look at it like this, it's going to look like it's going to be a circular shape. When you look at it like this, it will be a straight line because you're only seeing this part of the circle. So if I keep it perpendicular to everyone like this, you will be able to see only a straight line because the backside is not visible. Now what I can do is, if I place it in this way, it will neither look like a circle nor like a straight line. It will look like an ellipse. Okay. So that is the first visualization that we need to make. The next question is, if you look at the topic, we need to find the magnetic field on the axis of this current carrying loop. So what does an axis define, or how is an axis defined for a circular current carrying loop? So if you look at this, the center of it is here. The center is here. So if I take an imaginary line and make it pass through the center perpendicular to its plane. So this is the plane and this is the center. If I pass an imaginary line through this side and if I hold it on the other side as well, right, this is going to be the axis. Now what we are going to do is, for this circular current carrying loop, we are going to find what is the magnetic field on the axis of it. So the axis is obviously going to pass through the center. Now, this is going to be the radius, which we will take it as A. And let me say, the distance from the center to the point where you're trying to calculate the field is X. Is that point clear? So let us consider it to be X. Now, the question is, if I say that in this conductor, okay, so I'm placing it like this, no. Let's say in this conductor, the current is flowing in the anti-clockwise direction. How is it flowing? It is in the anti-clockwise direction. So at this point, how will the direction be? It will be in this way. It will be towards me. Okay. And where is the point? It is on the axis. It is on the axis. So from this point, if I consider a small element dl here, okay, first let me draw it. Let's say in this conductor, the current is in the anti-clockwise direction. So here it is going to be downwards and here it is going to be upward, and you're seeing it from this side. Okay, when you're seeing it from this side, when the current is anti-clockwise, at the top, the current is towards you, whereas at the bottom, the current is away from you. I hope you're able to visualize that part. So if I take a small current carrying element dl here, then here the current is going to be towards me, right? This is the direction. So what will happen at the bottom? Exactly in the symmetrically opposite point, if you consider another current carrying element, it will be in the opposite direction. It will be away from me. Okay. Now, For us to apply the Biot-Savart law, what do we need? We need to derive the magnetic field, right? But we are going to apply the same Biot-Savart law, which says dB is equal to mu naught divided by 4 pi into ideal sine theta, the whole divided by r square. So let's try to analyze each terms. Mu naught by 4 pi is a constant. I is the current flowing through it. dl is the element that we have considered on the surface, right? Next is, what about the sine theta? Sine theta, theta is the angle defined between the current carrying element and the line joining the current carrying element to the point. So this is the trickiest part here. Theta is the angle between current carrying element. So it is the angle between the direction of current and the line joining the current carrying element to the point where we are calculating the field. So in this case, where are we calculating? On the axis. Now observe, if the current is like this and the point is like this, right? So the line is like this. From here, I'm going to join. Let me call this as R. So this one is R. This is I. This is R. Now, what is going to be the value of theta in this case? Is 90. Because they both are in different planes. Are you able to visualize what I'm trying to say? See, this is the direction of current. This is the direction of R vector. When you look at it like this, it appears in this way. Actually speaking, it is like this. Right? It is like this. Anti-clockwise current. This is DL according to the diagram. Now, when you go to the top and see, it look like this. They both are perpendicular to each other. So in this case, the value of theta is going to be equal to 90 degree, and R is obviously known. R is the distance from DL to point P. Is that point clear? Are you able to visualize this? Ideal vector and R vector. Theta is the angle between ideal vector and R vector. So I'm taking only two vectors, two straws, where this is what? Ideal vector. This is, how are they? Perpendicular, right? So that's what happens. Is the point clear? So I take theta is equal to 90 and substitute it here. Then dB will be equal to mu naught divided by 4 pi into ideal. What is sine 90? 1 divided by, what is the value of R square? So R is basically root of A square plus X square, right? A square plus X square. So R square will be A square plus X square. Now the question is, how is the direction of magnetic field due to the small current carrying element? That is what we need to visualize. Okay. Now I'll give you time. Observe. This is ideal, no? Right. This is ideal vector. Remember, whenever you are finding the magnetic field, the direction of magnetic field is decided by the cross product of ideal vector and R vector. Okay. So another point to be remembered is whenever you are doing the cross product between two vectors, the resultant will always be perpendicular to both the vectors for which you are doing the cross product. Here, what are the two vectors? Ideal vector and R vector. So dB vector should be perpendicular to both ideal vector and R vector. Okay. So how is it going to be is what the question is. So when I curl my fingers in this way, right, you're keeping the direction of, you're keeping the thumb like this in the direction of current and curl the fingers. When you're curling the fingers at this point, how do you think your hand is going to come? Here, I don't have a hole, or else I would have showed it. So how is it coming? It is coming, look at my fingers. It is coming upward. So here the magnetic field will be like this. Because ideal vector and R vector are already perpendicular to each other. So how should dB vector be? It should be perpendicular to both. Meaning, if this vector is there, no, R vector is like this, no. So to that r vector at point P, dB vector will be like this. So this is the direction of dB vector. Okay, this is dl vector, this is r vector, this will be dB vector. Okay. Now, what I did is exactly at the symmetrically opposite end, we have considered an other current carrying element. But what is the direction this time? The direction of current is exactly opposite, right? So how is it? It is in this direction. And how is r vector? Like this. So how are they both with respect to each other? Again, they'll be perpendicular. Okay, they'll be perpendicular. Now the question is, due to this ideal vector, right, what will be the direction of magnetic field at this point? This is ideal vector, this is r vector. So dB vector will be perpendicular to both like this. In the sense, due to this second current carrying element at point P, dB vector will be in this direction. Okay. So the reason why I consider 2 dB vectors is it will be easy for us to follow symmetry. We could have done it with one also. Okay. So basically what is happening here is, from here you're joining r vector, no? From here also you're joining r vector, no? Like that, if you try to join r vector for every element considered on the circular loop, it will take the shape of a cone. Observe, it is taking the shape of a cone. Is that clear? Now, so is it clear till this step? You understood this dB vector's direction and this dB vector's direction. So what is the logic? How dl and r are? First take art name. This is dl, this is r. This is dl. This is r. How will I show a 3-dimension on it? It's only projection. So this is dl vector, this is r vector. When you look at it, it will be perpendicular. Are you able to visualize that part? So that's what happens here. This is dl. I didn't take a perfectly circular shape. That is why I told you in the beginning itself. When you look at it straight, when you look from this side, it looks like a circle. When you look completely from the other side, it looks like a straight line. Whereas when you look at particular angle, it looks like a ellipse. That's what I have taken. Okay. So, but still it is a circular current carrying loop. Whose phone? So if I take this angle to be theta, then how much will this angle be? This will also be theta because they are symmetrically opposite points. Okay. Now tell me one thing. If this is theta, how is dB vector with respect to r vector? Perpendicular, no. So what I will do is I'll resolve this dB vector into vertical and the horizontal components. Similarly, the second dB vector also into the vertical and the horizontal components. Okay. Now, this line and this line are perpendicular to each other. So how much will this angle be? It will be 90 minus theta. This line and this line are perpendicular to each other. Then how much will this be? Theta. So if I resolve this dB into vertical and horizontal components, what will be the vectors? It will be dB cos theta. Here it will be dB sin theta. If I follow the same symmetric pattern at the bottom also, then this angle will be theta. Then what will this be? This will be dB cos theta, and the other one will be dB sin theta. So dB cos theta and dB cos theta are cancelled. So what is the only magnetic field that is existing? So resultant magnetic field is equal to 2 times dB sin theta. Am I clear with this? So it is going to be 2 times dB sin theta. So if I need B net, what am I supposed to do? Integral of 2 times dB sin theta. So this will be integral of 2 into what is the value of dB? Mu naught ideal divided by 4 pi into a square plus x square. Is that clear? Now, the next question is, what is sine theta? So if I look at this triangle, this is theta, this is the opposite. So what is sine theta? Opposite divided by hypotenuse. So a divided by root of a square plus r square. Sorry, a square plus x square. Why did I write it like that? Because it is going to be a by r. What is the value of r? Root of a square plus x square. So if you observe, you are integrating the whole thing with respect to dl. You're integrating with respect to dl. If you see, all other parameters with respect to dl is a constant. Though x is changing here, right? It has nothing to do with dl. So all other parameters can be taken out and we'll apply the limit only for dl. Now tell me one thing. You considered one dl here and another dl here. So when this dl is traveling in this direction, this dl will start traveling in the other direction. Traveling in the sense, when I count all these dls, how many dls contributed together is giving me the net magnetic field? It is 2 dls, right? So what is the contribution of each dl over this network? Over this loop, how much is dl? How much is each dl moving? This dl, as it starts moving from here and it comes to the other end, what would the other dl do? It would have started here and come to the other end. So each dl is covering only half of the circle. So it is covering only half of the circle. So what is the circumference of a circle? It is 2 pi a. Here the radius of the circle is a. So it is 2 pi a. Since each dl covers only half of it, you need to take the limit as 0 to pi a. You will not take it as 0 to 2 pi a. Similarly, had I taken 4 dls, what should I write? 0 to 2 pi a by 4. The number of dls you consider, you should write 2 pi a divided by those many dls. So I'll take this 2 outside. 2 times mu naught divided by 4 pi. Okay. I will take a also outside. A divided by a square plus x square into a square plus x square power half. How much is that? A square plus x square, the whole power 3 by 2 and integral of dl from 0 to pi a. So what is integral of dl? It is L. So integral of L between pi a to 0, 0 to pi a. It is going to be this value only, pi a. So the final answer will be 2 will cancel this 4 twice. So mu naught a divided by 2 pi into a square plus x square, the whole power 3 by 2, whole power 3 by 2 multiplied with pi a. Pi and pi will get cancelled. What is that you are going to get? You will have mu naught a square divided by 2 into a square plus x square, the whole power 3 by 2. And this is the expression for magnetic field due to a circular current carrying loop where on its axis. Okay. And this expression is to be remembered. 1 minute. There is I here and there is I here. This I is there, no? So mu naught I a square divided by 2 into a square plus x square, the whole power 3 by 2. Is the point clear? So make a note of this. Play. Go. சொல்றேன் கேளு, நீ லாஜிக் புரிஞ்சுக்கோ. 4 எடுத்தா you will get 4 dB sin theta. 4 dB sin theta எடுத்து when you write 4 dB sin theta, when you integrate, how much will be the limit that you will write there? 2 pi a by 4 அப்படி எழுது. If you do that also, you will get the same result. But எவ்வளவு எடுத்தாலும் if you write only 0 to 2 pi a, you will get multiple answers. Then which one will you decide as right? அதான் சொல்றேன், இதோட physics முடிஞ்சிருச்சு. From here, math is taken. அது ஏன்னா you didn't write the limit for 2dl. You wrote the limit only for dl. But here, what did you do? Right. Here you wrote the result of 2dls. Okay, அதனால அப்படி எழுது. That's why that is a very tricky point. Write down the reason of why I took pi a. I explained the reason already. What is the reason you write? Why we are taking pi a? Because each dl, so you write it in bracket. We consider 2 dls. We consider 2 dls, out of which each dl will cover a distance of pi a. It's not 180 degrees. It will cover a distance of half the circumference. புரியுதா? இல்ல பார்த்து என்ன பண்ண அவன்கிட்ட கேளு, உனக்கு புரியுதா? புரியுதா? இல்ல அவன் தான் புரிஞ்சுதா? அவனுக்கு எக்ஸ்பிளைன். Basically, you will write 2 pi. It's very simple. Half the circumference. You remember it as 2 pi a divided by n, where n is the number of dls of this. Had you taken only 1 dl, you would have got dv sin theta. 2 dv sin theta. You would have only got dv sin theta. That time you will take 2 pi a. So, என்ன பண்ணாலும் numerator la the 2 தான் இருக்கும். Did you understand? அப்படி எடுக்கிறது, I am not taking for the result. I used a logic there. What did I tell? ஏன் அப்படி எடுக்கிறோம்? ஆமா, அவதான் கவர் பண்ணும். ஆமா, இல்ல ட்ரை. ஏன்னா இங்க என்ன இருக்கு? அதுக்குதான் லிமிட் எழுதுற. இங்க எவ்வளவு டிஎல் இருக்கு? forget about everything. ஆமா, ஒரே ஒரு டிஎல் தானே இருக்கு. அந்த ஒரு டிஎல் எவ்வளவு டிஸ்டன்ஸ் கவர் பண்ணுது? 2 வராது. when you integrate 2 is a constant. No, that's why I am telling that. எது எடுக்க வேணாம்? 2 2 தான் இங்க வருது ரிசல்ட். பிசிக்ஸ் பிரகாரம் 2 வருது. See, there are every derivation. Guys, listen. டேய் கேளுங்கடா. So, எந்த derivation எடுத்தாலும், okay, there are 2 parts always. Wherever you are using integration, I want you to remember this. One is, the first part will always be physics. Okay. So, if you see till this part, it is physics. After that, you need to start applying mathematics. That is why I'm stressing on the point. Whenever you are differentiating or integrating, you always need to take the differential coefficient into consideration. Based on that only, you will take the corresponding limits. If you observe in the previous derivation that we did, in this derivation, what did we do? I told you in the beginning. So dl was there, sin theta is there, r square is there. We didn't directly integrate it. What did we do? We converted everything to one variable. What was that variable we chose? We converted to d phi. We first wrote phi theta in terms of phi, and then we proceeded, right? So when you took d phi, you were only concentrating on how much the phi is getting covered, correct? So if you take the dl here, if a phi inga irukumbodhu dl is here. let's say this is phi 1. இப்போ இங்கே நீங்க வரும்போது dl would have moved down. கரெக்ட்டா? அதே மாதிரி எத்தனை dl இருக்கும்? You will have infinite such dls. But in this case, how many dls did we consider? 1. Okay. But what we did is we transferred this to phi, right? And then we took the limits of phi into consideration. Right? So here, if you observe, in this derivation, this is the only physics part. மீதி எல்லாம் என்னது? ஏதோ physics தெரியுது உனக்கு? இங்கேயுமே இல்லை. So illa derivation அப்படிதான். So always with physics, you will come to an expression where that expression is a function of one variable. இது நல்லா கேட்டுக்கோங்கடா. This concept is applicable for maxima minima also. Okay, you will be learning that chapter. In maxima minima, you have some questions where the surface areas and volumes are involved. You will use the same logic, except the fact that you will differentiate instead of integrate. So on the maxima minima concept, when you are applying also, what you will have is you will have a function of two variables. You don't have the concept of differentiation of two variables. In your syllabus, you don't have it. So you need to convert everything to a function of one variable and then proceed. So you can write one in terms of other with a given condition. Okay. The same logic is to be applied. Even whether it is physics or math, it's the same thing. We are only taking this integration as a tool to apply it here. Another, நான் எதுக்கு இந்த பாயிண்ட் சொன்னேன்னா, you are getting confused between this 2 and this 2. You should not take this as 2dl. No. You are getting this 2 because of what? Because of the resultant magnetic field that is occurring, and you applied physics there. Who told you the direction of dB? Is it math or physics? It's a right hand thumb rule, no? It's from physics. So dB is given by, the direction of dB is given by physics part. Due to those two dBs, which one is getting cancelled? The ones which are exactly in the opposite direction, and the ones which are in the same direction are getting added, and they are the ones which are contributing to the resultant magnetic field. 1 dB sin theta and another dB sin theta. So each dB sin theta is generated due to whom? Each dl. It is generated due to each dl. So with this, the physics part is over. After that, what you do is you will write the exact expression. After that, you should not think about how many dls are there or anything. Okay. So you get 2 dB sin theta when you are integrating it. What did we do? We just took dB from here and substituted. Right. After you substituted, you observe that dl is a variable with which you need to integrate. The next thing you need to check is there any other variable in this expression which is dependent on L? If it is dependent on L, keep it inside the integral. If it is not, take it out of the integral. So whether it is a constant or a variable is decided by the differential coefficient with respect to which you are integrating. So dl is the variable. So mu naught by 4 pi is a constant. A square plus x square. Why did I say it is not dependent on L? Because even if you change the value of x here, is there any effect that is going to be on dl? They both are independent parameters. So x is not dependent on dl. Similarly, what about the radius? It is a fixed quantity. It is the same circular loop that you are considering, right? So dl, a is also a constant. So a square plus x square will also be a. So what should you do? You should take everything out. So what is that you are left with? Your d. Now you start checking to arrive at this value of 2 dB sin theta. How many dls did we consider? 2. So the number of dls that you considered, the limit will get changed as 2 pi a divided by n, where n is the number of dls. Why is it happening? Because you're only seeing how much is each dl covering in one complete cycle. In one complete cycle, when this dl is coming here, this dl would have gone to the top. So they are equally covering the distances. Basically, what I'm doing is dl meaning in the cap. So the dl meaning is, let's say you take a white paper, stick it here, and the dl will show. If you keep adding one color, the white color to the book out dl. How much distance, at what distance do you stop? Say if the color of the green color, the green color of the green color. Integration only basically integrating and what is the basic meaning of integration? Adding joining things. That's what we do. You forget about differentiation, antiderivative, or other. Integration basically means you are summing up all the values. Simpler for the no, you have seen this no. Are you scared of this? Because you're scared. Are you scared of this? No, simple formula you had it right. Either திருப்பி போட்டா தான் the integration. Only difference and this you use it for discrete values. That is why you use in statistics. Statistics and discrete, one component to the you count. You take any discrete value into consideration, then you will add. Whereas continuous values are the use. Another integration when you talk about the function is continuous values. So continuous values, if you need to add everything, you need to use this symbol. You know, one of them is. When do you use it? Discrete, that's why you use it in statistics. This is for that's why you use it for functions. So when it comes to functions, probability level use பண்ணலாம், but you don't have it in syllabus. When you go for higher study, you can understand that whenever you are doing any, you would have heard about this data analytics, right? Famous course from where even IITs have started with PSC course with that. Data science. Whenever you want to predict the future, basically data science is the data which you are going to predict the future. It's all about probability. Simpler. Again, science was there. We're going to use the same mathematical tools. Instead of this tool, you use this. You difference and the time of development, you not have a pen and a paper, Excel, but the backend formula that is working, that is going to use. So you should have the knowledge of whether the result is correct or not. It's not a math. So you can use this for probability. You predict something, to predict the future. We generally use this. We call it as probability statistics for the existence. Integral. Start some other person again. You have it in your 10th, you have it in your 11th. So this is what I use for you. So this is just trying to give you an example. Next time when you're doing more, try to understand what it is. So you use this before you learn. I is equal to 1 to n. What do you have? Lower limit, upper limit. This is very nice. Each story given in different format. The minute difference is many people don't know this. Right use summation, right use integral. I hope you understood. So depending on the data set, you will choose whether you need to use summation or integral. The data set is required. The numbers are not connected. There is gap between the numbers. Discrete as 1, 2, 2, 3, 4, those are discrete. Suppose I have, you need to add all the numbers between 1 and 2. It is manually possible. If I say I add all the numbers between 1 and 2, now, then the number is 1, as you add 1.1, you can say 1.11. Like that, how many other ones I want, I can add. I have infinite data. It's continuous. So one term of the continuous is 3 data. At that time, I cannot use summation. Because I don't have any ready-made formula. The statistics are basically used for the another. You use arithmetic progression formula. 10 into n plus 1 by 2. Other model in this. But this can they have given formula of functions. Sorry, yeah. That's what you use, but it's an infinite series. Yeah. Because you have the factorial. Basically, those are the expansions of e power x sin. I'm not sure where you learned it. So there is, we use limit, no limit extends to 0 sin x there. No, sin x itself has an expansion, which is written in terms of factorial. So there you use something. Okay. So I hope it would make some sense. Because the question is, we know what is the formula on the axis of mu naught I a square divided by 2 into a square plus x square the whole power 3 by 2. Right. So when you want to calculate the magnetic field exactly at the center of the loop, see, the general formula is derived for a point which is at a distance of x from the center of the loop, right? Where the value came out to be mu naught I a square divided by 2 into a square plus x square the whole power 3 by 2, right? Now, if you see, the topic says you need to find it exactly at the center of the loop. So if this point P has to coincide with O, what should happen? X should be 0. So X should exactly be equal to 0. It's not an approximate value. You take it and substitute it here. Then what is going to be the value of B? It will be mu naught I a square by 2 into a square the whole power 3 by 2. A cube mu naught I divided by 2a. Okay. So here I want you to make an important note. If you see, due to an infinite length conductor, we get the value as mu naught I by 2 pi a for a point which is considered at a distance a from the conductor. Whereas for a circular loop, at the center, you get mu naught I divided by 2a. One common misconception is when we think of circle, think of circumference, 2 pi r. So what people do is they apply this formula here. Because look at the denominator, pi is there, no? They get confused. So when it comes to a circular loop, there is no pi in the denominator. When it comes to a linear surface, that is a linear conductor, there is a pi in the denominator. So please remember this difference. Am I clear with this? Are you able to understand the difference? So this is also a very, very important formula. We'll be using it many times. So it is going to be mu naught I divided by 2a. Right? You're clear with this? Shall I proceed? There are two more cases. We'll see it fast. See, at a point lying far away from the coil. See, at a point lying far away from the coil means, what can you conclude? X is very much greater than A. That is the meaning, no? So if I take this to be the coil, this is X and this is A. X is considered to be very much greater than A. So B will be equal to mu naught I A square divided by 2 into a square plus x square the whole power 3 by 2. When x is greater than a, x square plus a square is approximated to x square itself. Right. So here what will be the answer? Mu naught I a square divided by 2 into x square the whole power 3 by 2. So you will get x cube. Yeah, by 2 into x cube. Clear? Clear with this? Okay. See, one last condition is at an axial point, which is at a distance equal to the radius of the coil. Meaning x equal to a. So mu naught I a square divided by 2 into a square plus x square the whole power 3 by 2. Put x is equal to a here. A square plus a square 2a square. So this is going to be the value of b. So this will be equal to mu naught I a square divided by 2 into a square plus a square is 2a square. So how much will you get? 2 into 2 power 3 by 2. Correct? Because 2a square, 2 power 3 by 2. Inside you have a square. So a square the whole power 3 by 2. A cube, a square will cancel this a cube once. So you're left out with mu naught I divided by 2 power 5 by 2 times a. Mu naught I divided by 2 power 5 by 2 times a. See, these things can directly come as a MCQ question in your exam also. These are all the cases I am giving in your textbook. It is not there. Okay, so make a note of it. Breathe. அதை எடுத்து போய் டைரக்டா சப்ஸ்டிட்யூட் பண்ணி பாரு. Put x is equal to a. You write and see, you will understand. Clear with this? Yeah. So these are the three special cases. You saw only one derivation today, but yeah, it is worth because it's a very, very important one. Practice it. Next class we'll solve some problems based on this. And then I'll go to the, I told you, the second part of the chapter will not take much time. It is easy only. Since now you're clear with right hand thumb rule. Only thing is you revise the concept of cross product and come. I used I use orthogonal unit vectors. No, I'll be using some more of that concept. Okay, just revise it. Okay. Yes. Sir, there. X equal to a போடு. அப்ப என்ன ஆகும்? A square plus x square is 2a square. இங்க a போட்டா a square plus a square is 2a square. அதனால தான் 2 power 3 by 2. அதனால தான் உன்னை எழுத. Got it? Finished? Okay. Any questions? Here? Okay, we'll wind up.